Hi, today we're going to talk about evaluating geometric series. The term geometric series refers to adding the terms of a geometric sequence. So below you see the formula for evaluating finite geometric series. I want to emphasize that because there is another formula that you are going to learn later. The formula is right here. A sub 1 is the first term, R is the common ratio, and N is the number of terms that you're going to be adding. So let's go ahead and try to work with that. Those are the things we're going to need to know. We're going to start with sigma notation. So with sigma notation, what we have here is we're going from 1 to 5. So let's see what we have. What's the first term? We need to substitute 1 into this. So it's 2 times negative 3 times 1. And that's going to give you negative 6. The common ratio. This is actually an easy form to use because every time you go to the next term, you're going to multiply by negative 3. Because negative 3 has the exponent. So the common ratio is negative 3. And the number of terms that we're going to add, we go from 1 to 5. That's going to be 5 terms. So there's the formula. We're going to do sigma from 1 to 5 of this expression, and that's going to be the first term, negative 6, 1 minus negative 3 to the power 5, all over 1 minus negative 3. You have to be very careful here because this the value of r is negative. You need to put a parenthesis around that. You also need to make sure that you enter that as negative 3. Now it's all going to come down to doing math. This is 1 minus, when you do negative 3 to the 5th power, what are we going to get? That's going to give us 243. So 1 minus negative 243 all over 1 minus negative 3 is actually 4. And we just need to finish this math here. I hope you're not going to find it too intimidating. And after doing all that, you are going to get negative 366. That means if I were to take all these terms, all the 5 terms that I'm trying to add here, and add them individually, one by one, then that's the number that I'm going to get. Okay, let's take a look at the next problem. A couple more with sigma. So this one here we have this expression. This is very similar, except this is pretty much right there is your common ratio. We do need to find the first term, which is plugging in 1 into k. It's going to be 3 to the power 1 minus 1, which is 3 to the power 0, and I hope you know that it's going to be 1. The common ratio here is you keep multiplying by 3, so it's 3. And we go from 1 to 6, so we are going to have 6 terms. So we're going to set these up for the sum. So the first term is 1. 1 minus the common ratio of 3 to the 6th power divided by 1 minus 3. Okay. So we're going to do this math now. That's going to be 1 times 1 minus 729 divided by negative 2. 3 to the 6th power is 729. 1 minus 3 is negative 2. So it's going to be negative 728 on top, negative 2 on the bottom. And when we divide it, we are going to get 364 positive. That is the answer here. Next problem, similar format. So the first term will be going with 1 into the formula, 4 times 2/3 to the first, so it's 4 times 2 over 3 which is we put it as 4 over 1, and that's going to give us 8 over 3. This is our first term. The common ratio here will be 2/3, and the number of terms here is 4. So again, the first term, 8/3, 1 minus 2/3 to the 4th power, divided by 1 minus 2/3. So here you're going to have a few issues, and I would suggest using a calculator here to help you there. But you have to be very careful with 2/3, because when you're going to do an exponent, you're going to have to make sure that it is entered in parentheses, and then the exponent goes outside. So I'm going to type it in the calculator. And after doing all this, I'm going to get 520 as a simplified fraction over 81. Okay. This is not really a lesson dedicated to performing operations with fractions. That's for another time. Okay. Now we have problems that are slightly different. So here we have this geometric series that's given to us, and we want to find the sum of the first 7 terms. So we know the value of n. We know the first term. We need to find r. R can be found by dividing 2 consecutive terms. 14 divided by 2, for example, that's going to give us 7. The first term, 1 minus the common ratio to the 7th power. They just happen to be the same. So this is the common ratio. This is the number of terms divided by 1 minus 7. We don't want to do this by hand. This number may be quite large. So we're going to do the same thing. Type it in the calculator. And that's going to give us 274,514. Pretty large, but as we know, geometric sequences can have terms that go up very fast. Next problem, again similar to the previous one. This is the first term. This is the value of n. The common ratio here is going to be, if you take, since you have fractions involved, easier to do it as a division process. So negative 3 halves divided by 3, which is negative 3 halves times 1/3. And the common ratio will be negative 1/2. Use the formula. 3 times 1 minus negative 1/2 to the power 6 all over 1 minus negative 1/2. We want to put this in parentheses or brackets. Again, we don't want to get into the menial task of doing the step-by-step math. We're just going to plug it in the calculator. And as a simplified fraction, it's going to give us 63 over 32. Okay. There's a couple more. Find the sum of this. So this problem here is going to require some additional work because you don't know how many terms you have. We know what the first term is. We can find the common ratio by dividing 15 by 5. That's going to give us 3. But the problem is we have this term here, but we don't know how many we actually have in total. So this is what we are going to do to help us find it. We're going to remember the formula for the nth term of a geometric sequence, which looks like this. We're going to use this term here, which we have, to help us find the value of n, because that would be the nth term. So we're going to put 3645 here, and it's going to equal 5 times r, which we have, to the power n minus 1. Okay? So what we're going to do here is we're going to divide by 5 first. That's a fairly simple exponential equation. So 3645 divided by 5 is 729. So 729 equals 3 to the power n minus 1. And what you can do here is you could possibly remember that 729 is going to be 3 to the 6th power. So if you write that as 3 to the 6th power, that's going to equal 3 to the power n minus 1. And then all you want is for these two things, since the bases are the same, you want this to equal n minus 1, which means n equals 5. That means we are going to have, oh, I'm sorry, that's going to be 7. My apologies. N equals 7. So we have 7 terms. Okay? So now the formula, the first term is 5. 1 minus the common ratio is 3 to the 7th power divided by 1 minus 3. We'll let the calculator do the rest of the work. And that's going to give us 5,465. Okay. And the last problem here, it's very similar to the first few problems we did. There is one thing that I want to point out to you that we dealt with when we talked about arithmetic sequences. We don't start with 1. So the question is, how many terms do we have here? So the first term here will be when you plug in 3. I know it's not, it looks like it's supposed to be 1, but since we start at 3, that would be our first term. So that would be 2 times 3 to the power 3, which is 2 times 27, that's 54. The common ratio here, you should already be able to identify that as 3. The number of terms, so we start with 3, we go to 7. So 3, 4, 5, 6, 7, that's 5 terms. 54 times 1 minus 3 to the 5th power divided by 1 minus 3. I'll let the calculator do the work. And that's going to give you 6,534. And that's how it's done. I hope this helps.